guys, welcome to another video. In this video, I'm going to explain my favorite project which I have done recently. This is one of my latest projects. It is a RAG chatbot which is completely local, and I have collected data from Kaggle dataset. I will show it to you and everything how this project works. Let's begin. So the first thing is RAG. RAG means Retrieval Augmented Generation. How it works is let me show you a quick demo of RAG architecture. So this is client. If client asks a question, then uh, a retriever takes the prompt from the client and then it searches for relevant embeddings like tokens which are stored in vector database, and this vector database is our own data set, and it will send the prompt and retrieved context to the LLM. Then LLM will process the prompt more accurately based on the data sent as context from the vector database here, and LLM's response will be sent to the client. Why this method is used? So if an LLM is not trained on some specific data, and if we have that data, then there are two things we can do. First one is fine tuning the model. If we want to fine tune an LLM with our own data so that LLM can answer specific questions related to our data, then if the model has so many parameters, like it has billions of parameters, then it will be very costlier for us to train an LLM model. So the cheap and best option which is there for us is the second option, which is retrieval augmented generation. So what happens is, instead of training the LLM, we will use a vector database to send the relevant data as context to LLM along with the user's prompt, which means the LLM can process the prompt from this contextual data, which helps LLM to respond to answers specific to our own dataset without any need to train the model. Okay, so I hope you have understood what is retrieval augmented generation. So in this project, I have used ChromaDB, which is a vector store to create embeddings. I am using Fast API to serve the chatbot from backend side. And for the front end UI part, I'm using Next.js. Here it is. It is a single page application, simple, just for showcase. Let's run this Next.js project. Okay, it is available in port 3000. I hope this video is a bit lengthy, but it is very beneficial for you if you can understand. This chatbot is basically used to answer questions relevant to One Piece episodes data. See, this is a CSV file which I have downloaded this from Kaggle. Okay, so this has serial number, rank, trend, season, episode name, start, total votes, and average rating. Uh, this dataset has collection of up to 957 episodes of One Piece. Recently, I started watching One Piece, so I was just sort of thinking about why not make a like chatbot for One Piece episode data, because no one can remember 1,000 episodes names and ratings. Yeah, so what I did was, this is the vector store side program. So I used LangChain Ulama embeddings, ChromaDB, and document. So, uh, mm, why I'm using Ulama is because it is completely private to my laptop, completely it runs on my laptop, and it is very secure. So, I have installed these five models in my laptop because I don't have a GPU, so these five will be more for me. I'm using MXVAI Embed Large Latest, this embedding model to create embeddings. I load the dataset, load the model, database store location, path. See. So from the document, I mean CSV dataset, episode number, episode name, episode rating is taken as page content, which means it is main data. And extra metadata will be episode name, total words, and rating, which is I can add some other columns here also, but it is not much required. And next, IDs to map this data with with their IDs to search fast. So if the episode name is searched, then episode name will be ID and its data will be the relevant that document. Now, vector store.chroma collection name, passage directory, yes, which means it stores the embeddings in the folder here, chroma lines and db. That's it. Then if we run this, the embeddings will be created, and this retriever, I have attached this retriever to the vector store with search quarks k equal to 5, which means most relevant 5 documents will be retrieved at a time for each prompt. So retriever is used in another program. So this part is regarding the creating the embeddings for my track chatbot. Now this is the main program. Okay. So there are few things which I have experimented on my own. So first thing is I have used Langchain Ulama LLMs and Ulama LLM. Like I have used Ulama from Langchain library. No, Langchain framework, sorry. And then I did the program using a model, then prompt template and chain prompt and model. Like this I have used. It ran perfectly. There was no issues. Then what I thought was instead of just using text, why not use audio? Then I have added Google Cloud's text to speech and speech to text, which are free to use and mostly free to use. And it is good to build a program like this. Also, I have changed from using LangChain Ulama to directly using Ulama. I will show it to you how I used it. See, in the previous file vector.py, we have attached a retriever, right? We are importing it here. Now, this is fast API related one. Okay, let's go to the main program. First, input question. So, what this does is it will record the question of us for 10 star 44,100 milliseconds, which is approximately like 30 seconds or so. For 30 seconds, the voice recorder will be on, and if we speak our question, we have to speak our question. Then this audio will be converted to bytes, and audio is recognized here. Then this audio which is recognized is sent to, like it is shown here, asking is this the correct question you want to ask or not. Then if we say yes, then it will proceed here. And then for the retriever, we will use invoke method and give our question, which is the prompt. So you might be wondering how did this happen? See, this HTTP client is where the audio is converted into text using Google's Cloud HTTP. So this is the method, recognize method, wherein I have sent this config and audio file because audio did not mention it earlier. Next, the episode will be retrieved and it is printed here. Is this the correct episode? Yes or no? I just added this checks for just to showcase. We can just comment it. It is helpful for my debugging, but it is not needed. Okay, so get Ulama response. I am sending episode list and this is context data. This is the original prompt. Let's go to this get Ulama response method. See, it is taking data. So this is the URL where the Ulama models server runs. Ulama server runs locally. And this is the model data. I am using DeepSeek Carbon 1.5 billion parameter model. And I am sending this prompt dot format spreaded data. With why? Because just a second, let me show you. Yeah, see, this is the prompt template I am using. There are two parameters which I have to add them dynamically. Which one is episode list and another one is question. So I am adding them from the data here. Prompt.format spreaded data. Now temperature I am using one. It's not any specific reason, but just casually. I have used one. It is working fine. Now top P 0.9 and top K 40. Max tokens to 50. Stream false. Now, response request.post URL, JSON more data. After we get the response, we will return the response. Uh, the response will be coming here. I am printing the response. And since I am using DeepSeek model, I don't want that think part of DeepSeek. So that's why I'm splitting it here. Think and tag and just sending the formatted result. Let's stop it. Comment it. Okay. Now, this thing, which is the correct answer in text format, is sent to Google Cloud's TTS to convert it into audio. Now, the voice will be converted using TDS and then it is sent as a response from Google API and I will play the audio and store the audio file in local output audio folder. Like these are all the output audios which I've generated while testing this application. I have posted them in the GitHub repository. You can listen to them if wanted. Since I am saving the response audio file, I need to have unique file names. In order to generate unique file names, I am using timestamp based file names. For that, I'm using this method wherein I take time in integer and then take a random number between 1000 and triple nine, no, four lines, and return the timestamp and random number. It will be somewhat like this: output, some timestamp, and random number. This makes the file names very unique and not to clash at any time. So, in order to save the output file, I'm using local output audio, output, file name, MP3 format, store. That's it, out.write. And then I'm reading this file and I'm playing the output audio. Let's run this program, not using fast API, but just using main program only. Okay, let's comment this. Let's uncomment this. Okay, now again, let's run Python main.py. What is the name of first One Piece episode?
The first One Piece episode has the ID 1, and its name is I'm Luffy, the man who will become the Pirate King.
So let's stop this. Yeah, since I am using earphones, I'm not sure whether it is recorded or not, but I will show you a sample that it is recorded here. Uh,
The first One Piece episode has the ID 1, and its name is I'm Luffy, the man who will become the Pirate King. The first
yeah, that's it. How was the like when I first did this project, I was like very excited because like I was hoping to do it only for text, but my curiosity led me to do it for voice to voice transaction. So there are some things which I need to improve it, like streaming model and something. But I like its functionality now. And I have also implemented a front-end UI for this using Fast API backend. Now let's run this again. And since I'm using front-end, I did not implement audio functionality, only the text functionality is implemented, which is text response function here. What it does, it takes the user's question prompt, it sends to retriever, and episode will be retrieved. Then the context and the prompt will be sent to Olama response, and the text will be sent back to the front end. Okay, we did not make any changes, so I think this will be good. Now let's go to front end part. Yes, our front end is running perfectly. Localhost 3000. Let's ask what is the rating of One Piece episode? Let's say 324. Let's go. It is being processed here. See, yeah. So yeah. So what does it say? Okay. Hmm. See, there is no entry for episode 324 here. That means I don't have any data of the ratings of the episode 324 in the specific list. Couldn't say anymore. I wonder if it exists or else it is not. Okay. So since it is not there, according to my prompt, it has to answer I don't know. Okay, so its answer is correct because I did not include episode 324 in the data. I have removed it. Yeah, so I was like testing it. Let's ask another question. What is the name of One Piece episode uh, 943? Let's see, 943 is there or not? Yes, it is there. 943 here. Okay, let's see how it is being processed in the backend. Okay, so see, 943 episode data is retrieved. Yep. Here, the name of the One Piece episode 943 in One Piece is Luffy's distributed to include Voicebot. Okay, so that's regarding the bank chatbot project. In this project, I have explored one another thing. Uh, Instead of hosting this project cloud as a service, I tried to use uh, SSL technique using ngrok. Ngrok is a service which provides SSL tunneling. Like what happens is when I run uh, the website from my laptop on localhost, let's say 3000 port, ngrok will create a tunnel from port 3000 to its new web server, which is uh, managed by ngrok. And through this tunnel, the localhost 3000 port data is transferred to the web server and anyone can access it around without the need to host it anywhere. Like it is directly deployed from my laptop itself. So this is the intro complete file which I have already set up for this project using the command intro complete edit. And this is version 3. This is the authentication token endpoints. And the name of the kernel I have given is right chatbot. And the URL, I have got this URL free from Ngrok service. Anybody from the world can access my application using this URL. Once I start the Ngrok tunnel,
I have specified the upstream as 3000 because I'm running my Netflix standard on port 3000. So let's go. Let's run the unclock service. Clock start, right chatbot. See, it is connected. Session status is online. Okay, let's go. This is previously run on localhost. Now let's verify the intro channel service. Fairly here it is. So in the same way, anybody around the world can access my application in URL. I'll stop it now. Once I stop it, it is not. It says it is not online. It says it is offline. So that's it, guys, about this project. Thank you for watching. Back to next one.